Okay, so after decades of being, pushed to the fringes, psychedelic substances are making a huge comeback in the scientific world. And not as party drugs, but as potentially game-changing tools for mental health. So, how in the world do they work? Let's get into the science of how these compounds might literally be changing the structure of our brains.
And this is really the core question, isn't it? It's what's driving this whole revolution in neuroscience. We know that many of our current therapies have their limits, so researchers are asking, could psychedelics offer a totally new way to heal the mind? Honestly, for millions of people, the answer could change everything.
To really wrap our heads around what's going on, we're going to take a journey. We'll start with the big picture, the overall experience, and then we're going to zoom all the way in, right down to the molecules themselves.
This image here, it basically maps out that entire journey for us. See, up at the top, you've got the psychedelic experience, which is really shaped by your mindset and your environment. And that experience then kicks off changes all through the brain, affecting entire networks, entire circuits. And it all boils down to what's happening at the molecular level, way down here at the bottom. It's all connected.
So how do these compounds have such a massive, widespread effect? Well, this slide shows you why. They tap into the brain's major communication systems, especially the serotonergic pathways you see here on the left. Think of these pathways as the brain's information superhighways. They stretch into almost every single corner of the brain. So by getting on these highways, psychedelics can influence pretty much everything, from your mood to what you see and feel.
All right, now let's go deeper. We're entering what I like to call the cellular engine room. We're zooming right in to look at one of the most exciting discoveries in this whole field: how psychedelics can boost something called neuroplasticity. Simply put, neuroplasticity is just your brain's ability to rewire itself. It's amazing. It's how we learn, how we adapt. And what psychedelics seem to do is put the brain into this state of superplasticity. It's like they open up this window of opportunity where the brain can more easily build new connections and, crucially, break free from those rigid, negative thought patterns we can get stuck in. Okay, I know. This diagram looks incredibly complicated, right? But don't worry, we're going to make it simple. We're going to focus on just two key pathways that scientists think are at the heart of how these drugs change the brain. Think of them as two different keys, unlocking two very different doors inside our brain cells.
First, let's just look at the path marked by the red arrows. When a psychedelic molecule, say LSD, latches on to this specific receptor, it kicks off this whole chain reaction. This is the pathway that scientists are pretty sure is linked to the classic psychedelic trip. The profound shifts in perception and consciousness.
Now, shift your focus and follow the black arrows. This is where recent research gets really exciting. It shows that psychedelics also hit this second pathway. This one is a master switch for neuroplasticity. It directly tells the neuron to grow, to form new connections. So this is the crucial point. You've got one key for the psychedelic experience and a totally different key for the physical rewiring of the brain.
In this discovery that there are two distinct pathways, it leads us straight into the single biggest debate in psychedelic science today. If the therapeutic benefits are coming from that physical rewiring, then how much does the subjective trip actually matter?
This is the multi-million-dollar question. Does a person need to go on a profound, sometimes challenging hallucinogenic journey to get better? Or could we get the exact same benefits just by flipping that biological rewiring switch all on its own? The scientific community is totally split on this. So on one side, you have the no hypothesis. This camp says the biology is what really counts. If you can trigger that neuroplasticity we just talked about, you can get the therapeutic results without any hallucinations at all. But on the other side, the yes hypothesis says no, the experience is everything. It's what allows a person to gain these incredible new perspectives on their trauma or depression, and that psychological breakthrough is what's essential for healing. And the no hypothesis isn't just a theory anymore, it's already sparking a whole new area of drug development. People are creating what you might call non-hallucinogenic psychedelics. These are new compounds designed specifically to flip those biological switches for neuroplasticity, but without inducing a psychedelic trip. And if they work, man, they could become mainstream medicines way more easily. But we have to remember we are at the very, very beginning of this new chapter. Even the research itself points out that what we see in animal studies might not tell us the whole story when it comes to the incredibly complex human experience of healing. So the ultimate question is still out there. Is the magic in the molecule, or is it in the mind? The answer, whatever it is, could reshape the future of mental health care as we know it.